Rigid galvanized steel conduit, often referred to as RMC, is primarily designed and listed for use as a protective raceway for electrical conductors. Its primary function is to provide a robust, grounded enclosure for wires and cables, protecting them from physical damage, moisture, and other environmental factors. While RMC possesses considerable strength and rigidity, it is essential to understand that it is not inherently listed or designed for use as a structural support, such as a light pole. The structural integrity of RMC is primarily based on its ability to maintain its shape and provide continuous support to the conductors within when properly installed and supported according to the National Electrical Code, or NEC. When RMC is used as a light pole and secured only at one end, it is subjected to forces that it was not originally intended to withstand. These forces include wind loads, which can exert significant bending moments on the pole, especially at the base where it is anchored. Additionally, the weight of the light fixture itself contributes to the overall stress on the conduit. Over time, these stresses can lead to fatigue, deformation, and even failure of the RMC, potentially causing the light fixture to fall, creating a safety hazard. The NEC specifies requirements for supporting RMC at specific intervals to ensure that it maintains its structural integrity and provides adequate protection for the enclosed conductors. These support requirements are typically outlined in NEC Section 344.30. The specific spacing between supports depends on the size of the conduit. For example, for trade sizes 1/2 inch through 1 inch, the maximum spacing between supports is typically 10 feet. For larger trade sizes, such as 1 1/4 inch through 2 inch, the maximum spacing may be increased to 12 feet. It is crucial to adhere to these support requirements to prevent the conduit from sagging, becoming damaged, or creating a potential hazard. In the context of a light pole application, the absence of intermediate supports along the length of the RMC significantly deviates from the intended installation practices and compromises its structural integrity. The unsupported span of RMC is particularly vulnerable to damage from wind and other external forces, which can cause it to bend, twist, or even break. The NEC recognizes that certain applications require specialized support methods or materials to ensure the safety and reliability of electrical installations. Light poles are one such application where specifically designed and listed materials are essential. These materials, such as steel, aluminum, or fiberglass, are engineered to withstand the environmental conditions and mechanical stresses associated with outdoor installations. Steel poles, for example, are typically constructed from high-strength steel alloys and are designed to resist bending, corrosion, and other forms of degradation. Aluminum poles offer a lightweight alternative with excellent corrosion resistance, making them suitable for coastal environment. Fiberglass poles provide a non-conductive option that is resistant to corrosion and UV degradation. When selecting a material for a light pole application, it is crucial to consider factors such as wind loading, soil conditions, and the weight of the light fixture. A qualified engineer should be consulted to perform a structural analysis and determine the appropriate pole size and material to ensure that the installation meets all applicable safety standards and built-in codes. Furthermore, it is important to verify that the selected material is listed for use as a light pole by recognized testing laboratories such as Underwriters Laboratories or AL. Listed light poles have been subjected to rigorous testing to ensure that they meet specific performance requirements and safety standards. The listing mark provides assurance that the product has been evaluated and found to be suitable for its intended use. In addition to the structural considerations, it is also essential to address the electrical safety aspects of a light pole installation. The NEC requires that all metal parts of a light pole, including the pole itself, the fixture, and any associated hardware, be properly grounded to prevent electrical shock hazard. Grounding is achieved by connecting the metal parts to a grounding electrode system, such as a ground rod or a building's grounding grid, using a grounding conductor. The size of the grounding conductor must be appropriate for the size of the circuit conductors supplying the light fixture. NEC Section 250.122 provides guidance on selecting the correct grounding conductor size base and the overcurrent protection device for the circuit. Furthermore, it is essential to ensure that all electrical connections within the light pole are made in accordance with the NEC and that the wiring is protected from physical damage and moisture. Weatherproof enclosures and fittings should be used to protect the wiring from the elements, and all connections should be properly tightened and insulated to prevent short circuits and ground faults. In summary, while RMC is a versatile and widely used raceway for electrical conductors, it is not listed or designed for use as a light pole. Using RMC in this manner can compromise its structural integrity and create a potential safety hazard. Instead, it is recommended to use materials that are specifically designed and listed for light pole applications, such as steel, aluminum, or fiberglass. These materials offer superior strength, durability, and resistance to environmental factors, ensuring a safe and reliable installation. Always consult with a qualified engineer and adhere to all applicable codes and standards when designing and installing light poles to ensure the safety of people and property. The NEC provides comprehensive guidelines for electrical installations, including requirements for raceways, supports, and grounding. Understanding and following these guidelines is essential for ensuring the safety and reliability of electrical systems. When installing RMC, it is crucial to adhere to the support requirements specified in NEC Section 344.30. These requirements dictate the maximum spacing between supports based on the trade size of the conduit. For example, for 1/2 inch to 1 inch RMC, the maximum spacing is typically 10 feet. For larger sizes, such as 1 1/4 inch to 2 inch, the spacing may be increased to 12 feet. Proper support prevents the conduit from sagging or becoming damaged, which can compromise its ability to protect the enclosed conductors. In addition to the spacing requirements, it is also important to use appropriate support hardware. Conduit clamps, straps, and hangers should be properly sized and installed to securely fasten the RMC to the supporting structure. The hardware should be made of materials that are compatible with the conduit to prevent corrosion or other forms of degradation. When installing RMC outdoors, it is essential to use corrosion-resistant fittings and hardware. Galvanized steel conduit is typically used in outdoor applications due to its resistance to rust and corrosion. However, it is still important to protect the threads and cut ends of the conduit with a suitable corrosion inhibitor to prevent premature failure. Additionally, it is recommended to use stainless steel or other corrosion-resistant hardware to ensure the longevity of the installation. When connecting RMC to enclosures or other equipment, it is important to use proper fittings to maintain a watertight seal. Compression fittings and threaded couplings are commonly used to provide a secure and watertight connection. These fittings should be properly tightened to prevent moisture from entering the conduit system. In areas where the conduit is exposed to physical damage, it is recommended to use rigid metal conduit with a thicker wall thickness. Schedule 80 RMC, for example, has a thicker wall than standard Schedule 40 RMC, providing greater protection against impact and abrasion. When bending RMC, it is important to use a conduit bender that is designed for the specific size and type of conduit. Improper bending techniques can damage the conduit and compromise its structural integrity. The NEC specifies minimum bending radii for RMC to prevent kinking or flattening of the conduit. When pulling wires through RMC, it is important to use a pulling lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the type of wire being used and should not damage the conduit or fittings. After installing RMC, it is important to inspect the installation to ensure that it is properly supported, grounded, and connected. Any loose or damaged fittings should be repaired or replaced immediately. The grounding system should be tested to verify that it is functioning properly. The resistance between the conduit and the grounding electrode system should be as low as possible to provide a safe path for fault current. Regular maintenance should be performed on RMC installations to identify and correct any problems before they become serious. This includes inspecting the conduit for corrosion, damage, or loose fittings. The grounding system should be tested periodically to ensure that it is still functioning properly. In summary, RMC is a durable and versatile raceway for electrical conductors, but it is important to install and maintain it properly to ensure safety and reliability. Adhering to the NEC requirements for support, grounding, and connection is essential for preventing electrical hazards and ensuring the longevity of the installation. When considering the use of RMC for any application, it is crucial to evaluate the environmental conditions and mechanical stresses to which the conduit will be subjected. If the conduit will be exposed to excessive loads or harsh environments, it may be necessary to use a different type of raceway or to provide additional support to the RMC. Consulting with a qualified electrical engineer can help to ensure that the selected raceway system is appropriate for the intended application and meets all applicable safety standards. In addition to the structural and electrical considerations, it is also important to consider the aesthetic aspects of RMC installations. RMC can be painted or coated to match the surrounding environment, improving its appearance and reducing its visibility. However, it is important to use paints and coatings that are compatible with the conduit material to prevent corrosion or other forms of degradation. In conclusion, RMC is a valuable tool for protecting electrical conductors, but it is not a substitute for proper engineering and design. When used correctly and in accordance with applicable codes and standards, RMC can provide a safe and reliable raceway system for many years. However, it is important to recognize its limitations and to use alternative materials or methods when necessary to ensure the safety of people and property. Therefore, using RMC as a light pole without proper engineering considerations and listed components is not recommended due to potential safety hazards and code violations.